Okay, we're going to talk about solubility equilibrium and something called KSP in this section. So if you've ever had to have a barium swallow, or you know someone who has, and they're using that compound, you're swallowing it and it goes through your intestinal tract, um, your digestive tract and your intestines, and it shows if there's any problems in those areas. This barium salts are usually toxic, but we're going to talk about why it's okay to swallow this even though it's toxic in this section. So we're going to talk about solubility, whether something will dissolve in water or not, so that's solubility. And we'll figure out the math for something called KSP. So the solubility product constant is something called KSP, and it's a number, and we're going to show you how to do the math of this. So this KSP solubility product constant equals the product of the concentration of the ions, each raised to the power of the coefficient of the balanced equation. So the smaller the number, the less soluble something is. So here's some rules that would be really good for you to know. Solubility rules. I would recommend that you memorize these as best you can. And try to find an easy way to do it. You might want to go online and see if there's any easy songs or raps or something that will help you remember these if you're not good at memorizing things. But these are really helpful to know. What things are soluble, that means they dissolve in water, and what things do not dissolve in water. So let's look at, so for example, we were talking about that barium compound. Most things in you'll see barium a lot in here because that means a lot of things that are reacted with barium, that are hooked up with barium, will not be soluble in water. So that's why we can have that barium swallow and it's toxic, but it does not dissolve in water, so it doesn't get into our system, and so it's not harmful to us. So if you look at these numbers, really small numbers mean things will not dissolve in water. So aluminum hydroxide will not. Things with barium will not. Very small numbers. So a lot of these are really small numbers, like these, you know, really teeny tiny numbers. So a lot of things with silver will not react with water, will not dissolve in water. So silver chloride is slightly soluble in water. Most of it's going to stay in the bottom as a precipitate, and only a couple of little ions will jump up into the liquid phase and be solubilized with the water. So this is slightly soluble, so a little tiny bit will go up there, but most of it will stay in a solid form right there. So you might see this on water fountains or in your house. You'll see the scale that's slightly soluble, means most of it will be a solid, but some will dissolve in water. So we're going to figure out how to do this KSP value. So I'm going to show you how to figure out concentrations of the things that make this lead chromate solution. So lots of times you'll be given a number like this, and you have to find the concentrations of the things that form it. So first of all, you're given the KSP. You have to figure out what the reactions that's happening. So that's why you need to know your polyatomics and your ion charges so that you can figure out how these go together, because it'll just give you a name. Like this problem said, what is lead chromate? And if you don't know what chromate is, then you're going to be messed up. So this is lead chromate, +2, -2, so they go together 1 and 1. When this dissolves in water, when this solid dissolves in water, it's going to make lead and chromate. And so KSP is the product of the molarity of the lead times the molarity of the chromate. It's a 1-to-1 ratio, so we have no exponents up here. And this KSP is equal to this number, so we can just set them equal to that number and then solve for the unknowns. So we said KSP equals this, which also equals that number. And then since they're equivalent to each other, if I just take the square root of that, I'll get the value of each one of these guys. So that's a really common kind of problem. Given KSP, what's this concentration of something you don't know, of the ions that make it up. So this is a really common problem, so make sure you can do this kind of problem. Here's one to try yourself. Sometimes if you have two salts mixed together, you want to know if things will precipitate. So this is like a common lab that we could do. So if the product of the concentration of the two ions is greater than the KSP, you're going to have a precipitate form. So sometimes you'll have labs where you're given two solutions, you put them in together, and you want to know if you're going to make a solid. This is actually a precipitate right here. It's going to settle to the bottom later, but this is what we're looking for, precipitate. So a common ion is an ion that's found in both salts in a solution. The lowering of the solubility of an ionic compound as a result of the addition of a common ion is called the common ion effect. So sometimes if you have multiple additions of an ion, it's going to reduce the solubility of something. So we have saturated solution of lead 2 chromate. It's pale yellow. When you add a little bit more lead nitrate, you form more lead 2 chromate precipitates. So that's what's happening with a common ion. I'm not going to do too much with common ions, so I just want you to know the concept of it. I'm not going to give you questions on it, so I'm not going to go through this one with you. Alright, so let's try the quiz. So here's a typical problem. What's the concentration of a saturated solution of silver sulfide if you know the KSP? So see if you can set that up. Remember, there's going to be 2 silvers popping off of there for every 1 sulfur when this breaks apart. So pause me and then come back for the answer. Here's the answer. Alright, so see if you can do this one. You might have a little trouble with this one, but try it. Alright, this one's that common ion. I'm not going to ask you questions on that. So I'm going to stop for there. So this was a brief introduction into KSP, but be able to do those kind of KSP. I'm not worried so much about the common ion effect. Alright, talk to you soon.